Part 3 of the Maths Methods quadratic test solutions revolves around the use of the quadratic formula and also the discriminant to determine the number of solutions to a quadratic equation. This is work from 3H and 3I in the chapter. Quadratic formula is certainly something you need to memorize for studying maths methods in VCE. The quadratic formula helps to solve quadratic equations. If you have an equation ax squared plus bx plus c equals 0, its solutions, if you cannot use completing the square or cross method to solve it, or some other factorization method to solve it, you can use the formula, which is negative b plus or minus square root b squared minus 4ac all over 2a. That formula can be divided into two sections. The negative b on 2a equals the axis of symmetry, and the b squared minus 4ac inside the square root is what we call the discriminant. We use triangle symbol to represent the discriminant. In this particular example, you're asked to use the quadratic formula, which is this here, to solve this equation. A will be the coefficient of x squared, b will be the coefficient of x, c will be the constant at the end, the last term, so we have 2, 1 and negative 7. You then pop those numbers into the formula, which is over there, and you get negative 1 plus minus square root of 1 squared minus 4 times 2 times negative 7. Always use brackets when you're putting them into a formula like that. Helps you deal with the negatives, etc. 2a is, of course, 2 times 2. This will be negative 1 plus minus square root 1 plus 56. Well, let's just write that down. Minus 8 times minus 7 is plus 56. 1 plus 56 on 4. X will equal negative 1 plus minus square root 57 on 4. They're the solutions. There are two to that quadratic. Marks, one for remembering the formula, one for correctly subbing in and doing some simplification, one for the final answer. Second question revolves around the discriminant, the term that can be found inside the square root on that formula. It says use the value for the discriminant to determine the number of solutions. We know that the discriminant is greater than 0. There are two solutions. If the discriminant equals 0, therefore there are one solution. And if the discriminant is less than 0, you can't square root a negative number. If the discriminant is negative, there will be no solutions. You can't do that. In this particular example, A is negative 2, B is 9, C is negative 4. The discriminant is b squared minus 4ac is 9 squared, take 4 times neg 2 times neg 4 is 81 minus plus minus 2 4s are 8, 4s are 32. 81 minus 32, which is of course 49. Therefore there are two solutions. As that number is greater than 0, there are two solutions to that equation. It's worth noting that 49 is a perfect square, 7 sevens, so there are actually two rational solutions. You didn't need that to get full marks because you weren't asked for that, just asked for how many. But it is certainly worth noting that there's two rational solutions. 49 is going to square root perfectly to 7, so there's no square root in the answers like there was in the question before up here. They're irrational solutions. 1 mark for subbing into the formula, 1 mark for evaluating that to be 49, 1 mark for saying, well, therefore there must be 2 solutions. And then finally, we have an example that is in general terms. It involves an M. You will come across many such problems in methods. It's encouraging you or not allowing you to use your calculator to solve that problem, and requiring that you understand the underlying principle or theory. And that's the theory of the discriminant. The discriminant is, of course, b squared minus 4ac. We established in the last question up here what you need to know to solve this question. That a positive discriminant 2 solutions, a negative solution no discriminant no solutions, a 0 discriminant 1 solution. So first of all, we'll find the discriminant. A is the coefficient of x squared, b is the coefficient of x, c is the constant at the end for m and 4. The discriminant equals m squared take 4 times 4 times 4 equals m squared take 4 4s are 16, 4s are 64. That's part A. Part B says, well, what values of m will mean that there's only one solution? Well, for there to be only one solution, discriminant equals 0, so m squared minus 64 must equal 0, so m squared must equal 64, so m must equal the square root of 64, plus or minus, which of course is plus or minus 8. Part C. Find the values of m for which there are no solutions. For no solutions, discriminant less than 0. For no solutions, m squared minus 64 is less than 0. Now you can do this algebraically, but a really easy way, especially as we have the two values where it equals 0, is to draw a little graph of this discriminant, which I'm going to do over here like this. And it's down there to 64, negative 64, and it goes there like that, and there like that. And this is a graph of the discriminant versus m. And it cuts there at 8, and it cuts there at minus 8, which is what we established in part B. What values of m along this horizontal axis would mean that we had a discriminant value less than 0. In other words, underneath the m axis. Well, any value of m between there and there, along there, results in a y value down here, a negative discriminant value down there. So we can say that the answers by inspection are between minus 8 and 8. We represent that set by saying, well, the m lies between minus 8 and 8. When you write those sets, you start with the lowest number, negative 8. That's less than the m values, and m will be less than the upper value, which is 8. So that's the way you write it. Later on this year, you'll learn to use set notation, and if you did know set notation, it would look like this. The set of all m's such that negative 8 is less than m is less than 8. Did not need that notation to get full marks on this test. Part D, find the value of m for which there is 2 solutions. The values of m for which there is 2 solutions. That question should have been values for 2 solutions. The discriminant is greater than 0. M squared minus 64 is greater than 0. We can look on the graph and see where that would happen. Just get a different color, maybe green. discriminant is greater than 0, along the graph here, and along the graph there. Values of m that make that happen are the ones above 8, or below -8. Two different sections like that. By inspection, I can see that for any m underneath -8, say -10 down here, discriminant would be way up there to be positive. Say an m value, say +10 up here, discriminant would be up there to be positive. So we've got to write those two sets. We can do it from the graph, by inspection. We can say all the m's that are less than -8, and we can add to that all the m's that are greater than 8. In set language, that's a union sign. All the m's that are less than -8 and all the m's that are bigger than 8. We add those two sets together. That's good enough with the union sign, or even an and would do for this test. Later on in the year, we will learn to write that like this. The set of m's such that the m's are less than -8, union all the m's such that m's are bigger than 8. Okay, how did we mark this question? We gave 1 for finding the discriminant in terms of m. We gave 1 for knowing that to have one solution that had to equal 0, and then 1 for getting those two solutions, the plus and -8. We gave 1 for this diagram or some similar algebra if you did it that way. We gave 1 for this answer for the no solutions where m, the discriminant is less than 0, and we gave 1 for this answer where we found the values of m so the discriminant was greater than 0. 1, 2, 3, 4, 5, 6. I believe that question's worth 6. That concludes part 3 of the quadratic test solution.